All right. So let's get a couple people might have taken some extended spring breaks, but kind of jump into things here. So I in midterms I graded over spring breaks. You should be able to see kind of your grade on those. I put comments next to it of where I took points off. Obviously, multiple choice, so it kind of tells you which one you got correct or not. Any questions or anything with the grading, please let me know ASAP. But I will kind of get things changed around in Canvas today or tomorrow, kind of reflect more where your current grade is at, kind of weighting the midterm according to the syllabus, weighting the I-50s and the homeworks according to the syllabus, and kind of get you a better idea of where your grade's at after the exam, right? But you can see what your score was on that midterm going to Canvas now, okay? I will also, before Wednesday's class, get up the next homework. Obviously, we don't have a lot of new material, but I'm getting it out there early so if you want to, you can kind of start working on it as we kind of go through things, okay? I will also, I think I have most of them ready to go, so I should be over this afternoon and tomorrow sending out data sets for the project. We'll start focusing a little bit more on Fridays when we're looking at these readings. Try to start talking a little bit more about how we work with data in Excel, so kind of give you, more tools to kind of work with that data once you get it. I'll also get up the reading for Friday this afternoon. I'm kind of between two papers, but we'll see which. I don't know. I think after today I'll have a better idea about which one I want to do. So, with that being said, we'll kind of jump into things here today. So, we're gonna. The first half of this class is more of like industrial organization, kind of we're thinking about how the teams are making decisions. We're going to really, and we introduced it kind of towards the end, but we're really going to focus in on the labor market, right? And we're going to think about what kind of creates differences in wages of players and some kind of interesting dynamics that might exist. So if we think about the labor market, we've already kind of talked about the supply of labor is coming from the players, right? And it's kind of weird because now the individuals who are demanding, right, labor are the companies, right, the teams. So we've got the teams who are, or owners who are demanding labor, the players who are supplying labor, right? So let's keep going here. So if we think about what is the demand for labor rely on, right? So the way that we're going to write this, I'll come back here in a second, is our demand for labor is going to be really the marginal benefit to the team, right? Well, what's the marginal benefit to adding that player? It's going to be the additional revenue that that player brings in for every additional win they bring in. Now, the problem is, here's the amount of money that's brought in for each win. I then need to multiply that by the number of additional wins that the player is going to add to my team, right? So the total value, I think I'll have this in the slide, but another way we reference this is it's the value of the marginal product of labor from that worker. It's just now we're using slightly different terms because our product is wins, right? So it's the number of additional wins they're going to add times however much revenue I generate per win, right? And that would be the total value that player is bringing to my team, right, in terms of a dollar amount. So the demand for labor is going to be based off of how much value that player is bringing in to the team, or how much additional revenue that player will bring in by being added to the team. So that's where our demand curve for labor comes from. So if we're thinking across the 4 leagues, and we're thinking about so if I'm thinking about the different leagues, just for a second, assuming like this number of additional wins, let's assume that it's the same across every league. Probably not. We'll talk about in a second what's going to happen if it's not. But assume for right now, we're looking at the same like quality player in each league, right? They're going to bring the same number of additional wins to the team, right? Which league then would you expect to kind of have the highest demand for labor? Well, we want to look at kind of revenues, right? And revenues generated by each of these leagues. We look at it, so we go back to the data earlier in the semester. The NFL is a little bit higher, right? So you would expect salaries, right, or wages to be a little bit higher in the NFL than they are in some of these other sports, just based off of that amount of revenue they're generating per win. Now, that's not the only thing, right? So even though the NFL may have a larger marginal revenue per win, right? What's probably true about any one player in the NFL, especially if we kind of rule out quarterbacks, relative to just a single player added to an NBA team? Well, first of all, they're just one out of a smaller number of players on the team. So we expect that marginal number of wins that an NBA player adds might be a little bit higher. So the NFL's marginal wins that come from their labor might be a little bit lower. Now, this obviously varies across positions, right? So if we think about quarterbacks, so here, let's do an example here real quick. So we'll do, who do I want to pick on? We'll do, they get paid. We'll do kickers, right? So if I think about the marginal revenue per win, right, in the NFL is the same no matter what position I'm looking at, right? The marginal revenue that comes per win is always going to be whatever it is for that specific team. However, if I'm thinking about the number of additional wins that come from my quarterback, and we'll think about this as the first quarterback and the first kicker added to my team, which of these do you think is probably higher? Yeah, if I add a star quarterback, probably adds a much higher number of additional wins than if I add, a star kicker, right? And maybe you think kickers are important. I don't know. Choose the position you don't think is important, right? That you would think kind of has less influence or adds a fewer number of wins. So if that's the case, what would we expect? We expect the demand curve for quarterbacks to be higher. So how's that going to play out in our labor market? So we think about the quantity of labor. We've got wages or salaries up here. Here's our supply for labor. And let's just, to kind of simplify it, assume that there's the same supply of kickers and quarterbacks, right? We then would think, okay, here's my demand curve for kickers. If the marginal wins coming from quarterbacks is going to be higher, then I also know my demand curve for quarterback labor is going to be higher, which predicts not only do I see higher wages for these quarterbacks and kickers, but I also see a higher quantity that a team would want to add, right? And we kind of see that play out, right? I don't know if there's any team that carries, 2 kickers. I'm sure there's some, but usually like the practice squad, right? But every team has a backup quarterback. In fact, most teams have a third string quarterback, right? So this is the idea that it's not just, the demand curve for labor. It's not going to be like same star kicker is treated the same as a star quarterback. It's going to depend on how many additional wins does that position add or that player add to the team. Any questions on that before we keep moving here? Okay. So we're starting to think a little bit more precisely about kind of this demand for labor. If I can get my things to work. If we looked at some of these averages, just kind of look at some of the numbers, saying, okay, which one of these leagues has a higher marginal revenue per win, or maybe there's differences in positions. The NFL, the average, is 22.2. The average maximum salary is 22.2 million. The average salary of a single player is actually 3.6, right? So, we have quality differences, right? My quarterbacks or my high quality players make, a large amount of money in the NFL. My backups, my kind of positions that don't, maybe matter quite as much, we're only at about 3.6 million, which if we compare to like Major League Baseball, well, the average player in Major League Baseball makes a little bit more, right, than the average player in the NFL. And if we also look at the maximum in baseball, we see much higher kind of average maximum salaries that teams are paying. Now, that's also might partially because there's no cap in Major League Baseball, but some of this might be driven off of demand differences based off of the marginal revenue per win or the marginal wins that a player is adding, right? Maybe a star player in baseball adds a few more, more wins than a star player in I don't know, NFL or name your other league, right? I kind of have the ones from some older data from NHL and NBA, but you can kind of see the NBA quite a bit higher, even in the NFL and Major League Baseball, if you're looking at the average salary. And that's probably a byproduct of I'm one of a fewer number of players that are in the game, right? So I'm going to add a higher number of additional wins by simply being added to the team than I would if I'm added to an NFL team. And there's 50 or however many people are on rosters. Right? So just some of the numbers that we're thinking about, and even NHL being the lowest, we're still talking about the average of $3 million for players. Okay? So what's going to drive these differences, right? These are the averages, but like within this, like I've got some people making maximum salary, and obviously this is the average. That means some people are making a lot closer to zero, right? So you can kind of think about some other things that might be driving these differences. Okay. So our labor supply curve, we talked about our labor demand curve a little bit. We generally think about this as, if I pay you more, what do you think you would want to do more of? So if I'm telling you can work a certain number of hours for $10 an hour, the number of hours you choose there is, if I pay you $20 an hour, you're probably going to choose to work twice as hard or maybe twice as long, right? If I'm making more every hour, I might want to work 10-hour shifts instead of just 8, right? I think that's the intuitive thing that we generally think about. And this is the what we would call kind of a substitution effect. So when we're talking about labor supply and you choosing to supply hours of your labor, you're basically making a choice between working and not working, right? Or we call it usually leisure, labor, leisure, right? So if you pay me more, that wage goes up. Every hour of leisure I take, every hour I don't work, the opportunity cost is now higher, right? I'm missing out on making $20 an hour now instead of 10. So we generally think about the substitution effect between labor and leisure hours, that as the wage goes up, it makes leisure more costly. So I substitute and put more of my hours towards labor. Right? And that, I think, for most labor markets is what wins out, right? I mean, and I'll show you in just a second what could happen. We've got the substitution effect, but we also have the income effect, right? So for instance, if I were to pay you $1 million an hour, how many hours would you work in a year? I mean, if it was me, I'm probably banking up, work for 20 hours and I'm coasting, right? So if you increase the wage, and I'm not using an egregious example, but if you increase the wage enough, I start to actually choose to work less, right? Which is kind of counterintuitive, right? But it's because for most of us, we're always going to be in that realm where the substitution effect outweighs that income effect, right? We're probably never going to get a wage high enough to where we start working less, right? If you start paying me more per hour, I'm probably working even more. So what we can think about, though, is there could be situations, especially when we're dealing with people who are making millions of dollars, where our labor supply curve does something that's kind of wacky, right? So we're thinking about the quantity of labor and then kind of wages here. Initially, we think that, okay, yeah, as I pay people more and more, as that wage goes up, they supply more hours of labor, right? They're going to work more. And here, when we're talking about quantity of labor, one thing I generally talk about it in terms of hours, but a more practical thing would be, I had someone ask me, I think, before the exam a little bit about this, but like, well, I have to play all the games, right? I have to supply a certain amount I have to show up to practice, but we could also measure this as like the intensity. So this may not necessarily be measured in just hours, but it could be measured in like hours over effort, right? So you kind of think about this as like, maybe I still go to the same amount of hours of practice in games, but I'm much more focused. I'm putting in a lot more effort, right? I'm a lot more, putting in higher quality labor, right? So if that's the case, it's just harder to measure, the quantity of labor, but same principles would apply, right? So whether or not we're talking about just working more or putting in higher quality hours of labor, initially we think it's probably going to be increasing as I increase the wage. At a certain point, though, you said, like, if I'm getting $1 million an hour, we might start to work less. After this point, if I increase the wage past this point, well, now the income effect starts to take over, right? The substitution effect is way overshadowed by the income effect. And this might seem, for most jobs we think about, probably doesn't happen. But in sports, I'd say there's some really good examples. So I can think of one off the top of my head. So let's say, how do I want to think about this? So you can think about like Conor McGregor back before he was big. I don't know, maybe he was making like $10 million a fight. So he'd fight. Actually, I should do this differently. Put it up here. so I can kind of draw it to scale. So let's say he's making 10 million a fight. He decides to fight 3 times a year, right? Each fight he's making $10 million. Well, the problem is if all of a sudden he starts getting $100 million a fight, what could happen? Well, now, and we don't have to do 100, you could do like 20 million. Well, now I might only choose to do 2 fights a year, right? Because before, when I was only getting 10 million a fight, I'd fight 3 fights so I could make 30 million a year. If you're paying me 20 million a fight, I might only fight twice. I'm still making more money, but I don't have to put in near as much effort, right? Preparing for 3 different fights. I only have to prepare for 2 now. So it is very, you can look at, I think the UFC is a great example of this labor supply issue where you see the income effect dominate. Because once once fighters get a certain amount, start to get, above a certain amount per fight, you typically do see them fight less, right? Than they would like early in their career. Boxers, the same idea.
Is this kind of like how like in the NBA players resting?
Yeah, you could think of it as that. Although I think there's probably more dynamics going on there than just the income substitution effect with labor supply, because it's a little more complicated because it's not like they have their wage. So it's not that their wage is going up or down, but you're factoring in, they're projecting future wages based off of getting injured, right? So it's like you have the expectation of what your wage is next year times the probability that I don't get injured, right? And so I might want to take time off. So I'm reducing the probability I get injured. So if I go from like 0.9 times 20 million next year, I can go to 0.99 times 20 million. I have a higher expected salary in the future. That's probably how it's operating. So it's a little bit different, but same idea. Yeah. Questions? About here. Anything else I want to say? I don't think so. And exactly where this happens, where it backward bends, it's hard to say. It would actually be player specific, right? You can think about the cost to kind of working another hour. I may actually view kind of putting in more hours of this sport as more valuable than my leisure hours, right? So that substitution effect could be really, really strong, that for some players, it would never be overshadowed by the income effect, right? Or at least that income levels that we would see, right? Or salaries we would see them getting paid. So we've got a little bit more about labor supply. There we go. I kind of have that kind of labeled out or just written out a little more of what I was saying, kind of the models we're looking at. We've got 2 effects going on. The possibility we get this backward bending labor supply curve. I kind of already thought about this. You kind of think about it as, if I'm getting more per fight, right? My wages are going up, my wealth level is higher, I might hit that backward bending point of my supply curve. Let's see if I want to say anything else. I think we already talked about this. So generally, we have kind of our demand for labor, or kind of what the wage will pay, is the price of the good times the marginal product, right? The number of additional units the employee brings in times the price I can charge for that product. Well, now we already said the player is bringing an additional number of wins, and we multiply that by, well, how much am I making per win? That's going to be my marginal revenue per win, right? So we've got our demand curve, we've got our supply curve. We can start to think about some interesting situations. I think I'm going to skip this one, and I'm going to kind of start with this. Okay? So let's think about wages for different teams, because the demand for labor is not from the entire league. It could, each team has their own demand, right? So let's think about some different scenarios. So I'll start with large, small market, and I have another way we can think about this as well. So let's say I'm looking at my labor market, and I've got the supply of labor, and let's just assume, right, that this player is equally willing to play for any team, right? He has no preferences of what team. He just has a preference over how many hours he's working at these different wages. It's quite a simplifying assumption for right now. We'll complicate it later and kind of say, what if that isn't the case? We then can think about the demand that's coming from and actually I should just write this as supply. I don't know. Supply of labor, you can write SL. I'm gonna what do I do here? I'm gonna use a different subscript. Hold on. The demand curve for labor for small market teams, right? So supply of labor, demand for labor from small market teams. So we would predict that here are the wage and quantity, that small market, kind of the equilibrium from that small market team for this specific player. Now, if we remember that the demand curve for labor comes from the marginal revenue per win times the number of additional wins the player is going to bring in, what do you think is probably true? Sorry, large. About the marginal revenue per win from a large market team relative to a small market team? Probably higher, right? Because these larger markets, right, they've got higher populations, they've got more available income. I'm sure New York sells way more jerseys than, the Miami Marlins or wherever they are, right? And so that might be the case. Miami's got some cool uniforms, but you get the idea, right? We have differences in small, large markets. Larger markets, we would expect to have a higher marginal revenue per win. Now, there's other things that are involved, right? Like how good the team is doing. We could go into other aspects, but for this one specific thing, ticket revenue, we generally think larger markets have a higher marginal revenue per win. So what's that going to do to my demand curve? It's going to increase it. So we would actually predict that in larger markets, we have a higher number of players that are going to end up wanting to work there and end up trying to work there, or even if it's not the number of workers or the number of hours, they're putting in more effort when they're in the large market. And then we would also predict that the wages in those large market teams, they're able to, they're going to pay more money, right? Because if you think about, let me think of a good relevant example. So Aaron Rodgers, that's actually a really good example. Aaron Rodgers right now, right, is playing for arguably one of the smallest markets in any sport. Green Bay is a wild market that exists even, right? So it's a very small market. So yeah, he is a high quality player. He is going to bring in a large number of additional wins. But for that small market, Green Bay, each one of those wins isn't worth as much. So if I've got to pay you $60 million, but the number of wins you bring to the team is only an additional 40 million, I'm actually losing out on having you on my team. And so what might be true is there's another team out there in a larger market, I'm going to say it's the Jets in New York right now, or New York, New Jersey. That larger market, yeah, Aaron Rodgers is going to be just as good as he was when he was in Green Bay, right? He might bring in the same number of additional wins. He's the same quality player. This is really what the marginal wins is capturing, is the quality of the player. But that large market, each win is way more valuable. So that player is going to be way more valuable to the large market team. So what's going to be the case for them? Well, they might be willing to pay him $60 million a year because he's going to bring in an additional $80 million if he's playing for New York, New York team versus Green Bay, right? So I think if we're looking across the different size markets, we would typically think of larger market teams are going to be willing to pay a higher amount for the same quality player. So why is that a problem? It leads to something we've already talked about. If they're willing to pay a higher wage, yeah, they're probably going to end up with these higher quality players, right? More players are going to choose to go to the large market team. Competitive balance takes a hit, right? So, this is just one kind of way to analyze that, right? That it's going to be working through that labor market, that they're going to be willing to pay higher wages, and that players are going to be then more likely to choose that team if they have the option, right? It also might be a reason why we see large market teams trading for players, right? Because essentially, any value between these wages, right, is going to work for both sides who want to make that trade or whatever it is. Questions on that before we keep moving? I'm going to complicate this a little bit. Where did I put my? There it is. So we've got these large markets. What could be true? So let's think about, we'll use the Aaron Rodgers example. So let's say this was his supply of labor for the small market, right, for Green Bay. Potentially, right, if he thinks that if he has certain preferences that he would rather continue his career in Green Bay than going to New York, then playing for New York is going to be more costly, right? If for whatever reason he has some intrinsic utility that's driven by playing for the same team his entire career, staying in a community that he's been in the last however many years, potentially going somewhere else would then be every hour of labor is more costly there, right? Because I'm giving up whatever I valued in Green Bay, right? So if I have higher costs, remember, the supply curve is really just telling me the marginal cost. So if in the large market, at every single quantity of labor, my costs are higher, right? So we can kind of think about it as the marginal cost of this larger market may be higher, which would then say, okay, in this large market, they can't get away with paying this wage anymore. They'd have to actually be willing to give, oh, what is this? I'll call this W. This is the large market kind of after this other factors in, right? So we could have kind of these supply curve differences as well between the small and the large market, right? Problem is that this is the case. If this is what it kind of looks like, you might end up with in the large markets really have to pay a lot for this player, which can maybe, you know, if we have salary caps, less money to kind of give to other players, maybe this kind of helps with the competitive balance issue, right? But it's not a guarantee that we have supply differences, right? There's probably some players and there may be no preference between the large and the small market, or it may work in the opposite direction, right? In fact, before I do this, any questions on this before we keep moving? So we can have differences in the demand curve for labor between teams, small and large market, differences in supply curve as well, right? So I'll go through another one that is probably a little more relevant, perhaps. To kind of think about what we might see play out with small and large market teams. Okay. So let's say I've got my demand curve for large market teams, and I've got my demand curve for labor from small market teams. Let's say, where do I want this to be? Like right here. So this is my supply curve in the small market, right? So our equilibrium going to be in the small market. We see this quantity of labor, and this is the equilibrium wage. Now I described a scenario where, I don't know, Aaron Rodgers is nostalgic for staying in Green Bay, and so the costs are higher to going to New York. Let's assume we have a rookie, right? And NFL draft's coming up, and he's thinking about these large and small market teams, and which one would he rather end up on, right? Or which team would he be willing to supply more labor to, right? Even if it's just that once he's there, he'll work harder, right? Put in higher quality labor hours. Well, if I go to LA, right, as a Los Angeles, as opposed to, I don't know, I'll pick on Indianapolis, right? What do you think is probably true about outside opportunities in LA in terms of like, can I generate money through ads? Can I generate money, you know, doing appearances even in LA versus Indianapolis? It's a lot higher in LA, right? It's one of the reasons why LeBron James went to LA, right? Yeah, the wages matter, right? But if I'm going to a large market and there's more opportunities, well, then if I'm not in LA, it's kind of like if I'm in a small market, I have a huge opportunity cost because by being a star player in Indianapolis, I'm not a star player in Los Angeles where I could make way more money. So being on these large market teams, it's actually like the marginal cost is smaller, right? Because by being in LA, I'm not foregoing these other opportunities. I'm able to, you know, make more money off of ads, make more money, or maybe be in movies or something like that. So it's probably more likely, unless you have like this nostalgic thing that I kind of gave you an example of, it's probably a little more likely that in the large market, we actually see the supply curve be a little bit higher because of these other opportunities that would exist in these large markets, Los Angeles, New York, Chicago. So we may actually see, I tried to draw this and I didn't quite get it, so just assume I drew the shift a little bit larger. I didn't quite get it lined up. So what we might see is, yeah, the quantity of labor supplied in those large markets will be higher, but I might be willing to take the exact same wage in the small and large market. Why? because I might make $0 in Indianapolis outside of my playing salary. Whereas in LA, I might, being paid the same by the team, but I'm making an additional 10 million by, being a spokesperson for XYZ, getting involved in commercials or whatever it is, right? So that can kind of, we might see that mitigate the difference between small and large markets. We could have that supply shift kind of going the other direction as well. And that seems like a very relevant thing. Most of the time, like in the real world, like we're going to have all these things happening at the same time, right? You might have, I'm sure Aaron Rodgers feels nostalgic about staying in Green Bay. That factors into the cost. He probably also looks at New York, thinking about there's some pretty big opportunities there. That would factor in. So we likely have a lot of these things happening at the same time. We're just kind of individually analyzing how each one of them would kind of push these equilibrium wages between small and large market teams. Any questions before we keep moving here? All right. What do I want to do here? Go back to the slides here. I think I skipped over this. It's kind of interesting to think about. So I'm hesitant to say this because it's not. Well, we'll go through it and you'll see why maybe I'm hesitant to say it. But let's assume we're comparing the wages paid under a perfectly competitive market and a market where the employer has a monopoly in the product, right? So we think that most of these teams, they are monopolists, right? They're monopolists when it comes to supplying professional games of whatever sport we're looking at. So they're a monopolist in the product market. Excuse me. So if we think about the differences here, if I have the demand curve for labor, when I've got a perfectly competitive market, that's going to be based off of the marginal revenue per win in a perfectly competitive market times however many wins that player's at bringing in. We know that in a perfectly competitive market, the price is equal to the marginal revenue, right? We kind of have, perfectly competitive. I can't get away with charging a price any different than anybody else. So whatever the equilibrium price is, that's how much I have to sell for. That's the additional revenue I earn, right? So in our context, right, we can kind of think about this as, this would be like the dollar amount that I'm making per game. Okay? That's the price per game. It's not like they're selling, they sell ad rights and things, but they're thinking about more of like the dollar value of each game to these teams. If we have a monopolist in the product market, so we think about, I don't know, this is like the quantity of games, got demand, marginal revenue, we could even do increasing marginal cost. We know that, which is kind of reflects supply. We know that the perfectly competitive, I call this like the dollar amount of the perfectly competitive, how much each game is worth to that team. If I'm a monopolist, I actually restrict output, but then I go up the demand curve, I'm able to make a little bit more money per game. Okay? So why is that potentially good? Well, if this is the additional revenue that I'm making per game, then when I'm thinking about that demand curve for labor that comes from a monopolist, I might bring in the same number of additional wins, but that marginal revenue per win for a monopolist or the monopolist in the product market, it's going to be a little bit higher, right? So because their product, they can get away with charging more for their product if they're a monopolist, their workers, as a result, become more valuable, right? Because now their workers, for every additional unit they add, it's not just adding whatever the perfectly competitive amount was, it's now adding whatever this higher monopolist price or kind of amount. Right? So being a monopoly, working for a monopolist, if you're able to get a job there, is actually good. I mean, I actually predict that you would be paid more, right? Now, the problem is if they're a monopolist in the product market, they're potentially a monopsonist in the labor market. We're kind of assuming here, because we have players that are able to move freely, they don't have monopsony power. So in the context of our sporting examples, they're a monopolist in the product market, but they're not a monopsonist in the labor market. So that kind of works out well. But in, outside of sports, or if we're thinking about, I don't know, sports that are much more competitive, well, if they're a monopolist, or sorry, sports that are a lot less competitive, if they're a monopolist in the product market, they may also be a monopolist in the labor market. Here, we're assuming that they're not, right? But it's not like a wild assumption. I know that we don't have the reserve clause. It basically is. There's no monopsony power in these, at least, main professional leagues. Does this make sense? I'm getting at here. Any questions on this? So, if the demand curve for labor is higher for a monopolist than it would be for a perfectly competitive team or a perfectly competitive industry, we could think about, and I'll just draw a quick line. I think it's kind of self-explanatory, but we've got our supply curve for labor. Here would be our demand curve for labor from a perfectly competitive team. Here's our demand curve for labor from a monopolist. It would kind of predict that the wages we see paid by a perfectly competitive team are going to be less than that paid by a monopolist. So this might be one of the reasons that kind of help explain why we see, right, salaries be so high in these professional leagues. Because almost every league, like, the team kind of has somewhat of monopoly power over providing this, providing the games. Any questions on that before we keep moving here? Okay. Let me zoom out a little bit here so that when I come back, it's not crazy. Where are we having time at 15 minutes? Okay. All right. So, I mean, I kind of probably jumped the gun on this. I should have this slide earlier, right? We've been identifying these equilibriums, right? Where does the labor supply equal our labor demand, right? And kind of using that, we can make different predictions about whether or not equilibrium wages will be higher on some teams or lower on others, whether or not the equilibrium number of workers or just hours of labor supplied by an individual player are higher or lower on different teams. And I kind of already alluded to this, like the equilibrium quantity of labor, right? The quantity of labor may not be like the number of players that go to a large versus a small market team. It may be the number of hours or the quality of hours supplied versus that, to that large or small market team. Let's do. I think I'll save this for next class. I want to try to. Yeah, this is what I wanted. Okay. So I wanted to go to some actual data, right? So we've got kind of these predictions, right? But so what should be true is if I can add a higher number of additional wins to a team, that's going to push up the demand curve. I should be getting a higher wage. This intuitively makes sense, right? If I'm a higher quality player, adding more wins to that team, I should expect to then be paid a higher wage. So if we think about the demand curve for labor, the value of the marginal product of labor, it's going to be the marginal revenue per win times the number of additional wins that a player brings, or the change in wins from having this player. So what this paper does is actually estimates kind of what change in wins are coming from every player, right? So we're going to do, it has essentially all this data on player performance, so the number of points, and I'm sure it was like points per game, rebounds per game, steals per game. And then they ran this regression where they then obtained coefficients on each one of these things that predicted, okay, if you scored one more point per game in a season, how much did that increase the number of additional wins that the team had? Right? So they had win data, they had this player kind of performance data, they ran this regression and obtained all these coefficients. So give a little more context here. And I'll probably just use like points just to make the case. I won't write out every single variable they had. But you can think about this as, if I'm looking at what the change in wins was from a player who scored one more point per game, right? If we're measuring points as kind of per game, I could obtain whatever these coefficients are. And I don't know, let's say it was 0.2, right? I could then say, okay, this specific player, they averaged 20 points per game. So if they averaged 20 points per game, what's the number of additional wins they would add? Well, 20 times whatever that coefficient is, right? If on average, each additional point per game by a player is worth 0.2 wins to a team, if I then get a player that has 20 points per game, he's going to bring in 20 times 0.2 additional wins to the team. So if I obtain these coefficients, I could then go through every single player and predict based off of however many points they scored per game, I could predict how many additional wins they're going to add. Now I'm just using points here. We don't have to just use one variable. to make our predictions, if I can get back here, there we go. I can use multiple variables, right? It just becomes more complicated. I would have a coefficient on rebound, coefficient on steals, et cetera, et cetera. I would then, for every player, just plug in their numbers and get their predicted number of additional wins they would bring to a team. Well, once I know that, if I can figure out the marginal revenue per win for each of these teams, I can actually figure out how much these players should be paid, right? So that's what they do. They kind of had some revenue data. Now, they did this for like the average team. It's a little bit naive because we know that every team is going to have a slightly different demand curve. But if we look at the overall kind of average marginal revenue per win, we can then compare and say, okay, is this player being paid more or less than what they're worth, right? Because I can predict how much they're worth. It should be whatever the average marginal revenue per win is in NBA times whatever the change in wins that was predicted for that specific player based off of their performance statistics. Right? So obtain these coefficients, make these predictions. And kind of interesting about this thing about this paper is a little bit older. You can kind of see things like LeBron James was predicted to make 28.9 million. And the year that the study was only making 17.5. He then had someone like Tyson Chandler, he produced an additional revenue of 12.2 million, but was only being paid 13.6, right? And then you go through, there were some players that were overpaid, right? You can predict how much they should be paid, look at their actual wage and see that they were actually overpaid. So why are these values different, right? So what you can do, and this is a little bit outside the scope of this class, but just mentioning it for, I think, sake of completeness. We can predict how much what their wage should be using this model, right? You can also look at the actual salary data and then back engineer what coefficients the league is using on their statistics. So just replace kind of the value of the marginal cost of labor, replace that with their actual wage. And then you can compare those coefficients to the coefficients you found running this regression. This regression tells you how many additional wins that were added. You use actual wages. This is like kind of, allowing you to see like this is just how much they're additionally paying them for these statistics. And those might not line up. And so they compare the coefficients between this regression and regression with actual wages, not just predicted wages. And what they find is teams are overpaying for points and they're underpaying for things like rebounds, steals, assists. Right? So it's kind of interesting. You can do this with any sport. Although I don't think I've seen anyone do this outside of the NBA. Positional differences get kind of tricky in other sports, but you could like hone in on one position and figure out, what are teams overpaying for in terms of the statistics from these specific players. And it's really just running these regressions, comparing those coefficients, right? From the predicted wage and then the coefficients from the actual wage that's being paid. So just to maybe be clear here, if I was just using points, I would have kind of the predicted number of additional wins. So it'd be kind of like whatever that predicted number of additional wins times the marginal revenue per win. That's how much I'm predicting they get paid. Because this, right, is telling me the number of additional wins, or it's essentially telling me marginal wins coming from labor times the marginal revenue per win. If I then run a regression, and I could actually take, I probably would want to do this, divide it by the marginal revenue per win so that it should kind of give me the predicted number of wins, and then run that same regression, all right? I'm using the actual wage that was paid. Now this coefficient will tell me how far off away is that from what they should be, right? How far away is this coefficient from what it actually should be? Now, like I said, there's also differences in like, we could really probably make this a little more complicated because there's differences in demands for each one of these teams. So just because you're adding the same number of additional wins, if I use the marginal revenue per win average across the league, well, I know that LA's is going to be higher than Oklahoma City's, right? And so I would probably want to do some adjusting there. I don't think the paper did a great job at that, but it is an interesting way to start thinking about how we can use actual data to see if these models that we were going through actually are supported, right? Do we see larger market teams paying more, right? Do we see higher quality players being paid more, right? And the kind of higher quality thing is looking at this marginal wins, right? Or the wins added. Any questions on that idea? Thinking about coefficients, we're getting a little bit more into regression here. 5 minutes. I think we might save this for next class. I skipped something else too. What did I skip? Oh, roster size. We'll do this one. So let's say we are just thinking, and this to give you an area where this is going to be much more applicable. Let's think about, there's really labor markets for every single quality of player, right? Or for every single position potentially. So let's just think about this as the market for like backup players, right? So because roster limits probably don't come into play if we're thinking about high quality players, right? You know, the first player that we're adding is always going to be the best. So the roster limits are really affecting kind of the people that are last added to the team, right? So our lower quality players. So this is kind of the players we should be thinking about when we're thinking about this labor market. So we might have that there's some supply of labor, right? These kind of lower quality players are willing to work for, you know, however many hours, right? Or supply this amount of labor for all these different wages, right? There's some player who would play, and here we'll think about this really as the number of workers, right? So there's some player who would play for this wage, the next player would be willing to play for that wage, so on and so forth. Right? If we then have the demand curve for labor, looking something like this, potentially based off the demand that the team has, we get whatever this number of workers is in the equilibrium, right? So this might be something like, I don't know, we add 10 kind of backup players for whatever the lowest contract we're writing is, right? Maybe those 10 reserve players, we're paying each of them $150,000 or something like that, right? You think of this also as really applicable to like practice squads, right? Well, now the league comes in and says, well, look, we know that you'd like to on your roster carry, I don't know, 40 reserve players just in case, things go bad. And yeah, you might only be paying them $150,000, but we're going to limit the roster sizes, right? You can only carry so many reserves. What's going to happen if I have a roster limit set? Well, I can't employ that player, or sorry, any number of players past this point. So I'm we'll call this RL for roster limit. I guarantee that I'm going to get fewer players on the roster if I set an effective roster limit. But what's also going to be true is that by setting this roster limit, we now know that teams are willing to pay. What am I going to call this? We'll call this RL, and we'll call this upper limit. So the upper limit of what wages will kind of result in is teams will be willing to pay up to this higher amount now. The only problem is we also know, we'll call this like the lower bound. We also know that players would be willing to supply that labor for a lower amount. Okay? So what's going to be the resulting wage? We don't know. Somewhere in that range, right? We're going to have some bargaining, some negotiating going on. If we had someone have a little bit more power, so if the players union had a little bit more power, we might see that these roster limits then kind of actually push the wage up, right? If the union has a little bit more power so that they're going to be able to get away with getting the wage closer to what the team would be willing to pay, we might see the wage go up to here. If we didn't have a union, if we go back before players union existed, and maybe we had the reserve clause still exist, well, then we'd probably see the wage get a little bit closer to here, right? Because the teams would have a little more power in negotiating and bargaining. And we'll go through some bargaining stuff here I don't know, this week, maybe next week. But for now, we just know that the new wage will be somewhere in this range after we have this roster. Questions on that before we keep moving? Okay. I think I'll leave it here for today. So I'll get that next homework up. Probably able to start working on it a little bit just based off what we've talked about today. But I just want to get up there so you can kind of work along as we cover the material. And don't have to save it kind of all for the due date. Okay. All right. If you guys have any questions over those exams, like I said, please reach out. Make sure you let me know and look in your emails for some data over the next 24, 48 hours.